Today we're going to focus on another concentration calculation, something called molarity in Concept E. Concentration measures the amount of substance per unit volume. We discussed this in Concept D. Molarity is specifically the concentration of a substance in moles of solute per liters of solution. So this is the first calculation we've done this unit that involves moles as part of our measurement. All right, the molarity is going to be moles of solute over liters of solution, so thus we express our units as moles per liter. We also can use a capital M to represent the moles per liter. All right, our first practice problem, we're going to be finding the molarity of 100 milliliters of a solution that contains 0.25 moles of a dissolved solute. We're going to convert all the volumes to liters because we have to have it in liters. So 1,000 milliliters is equal to 1 liter. You would set up like the railroad tracks for this. It just happens to be using multiplication signs specifically. So 100 milliliters times 1 liter divided by 1,000 milliliters gives us 0.1 liters. Now that all of our volumes are converted to liters, our unit is already in moles for our solute, so we can go ahead, plug in our information, and then when we do the division, we get a 2.5 molar solution. All right, for our next practice problem, we're going to be finding the molarity of 500 milliliters of a solution that contains 4.9 grams of a dissolved sulfuric acid. So here, again, we're going to, instead of having our number given to us in moles, we actually have to convert to moles. So the way we're going to do this is adding up our GFM. We've done this a bunch of times throughout the year. We get 98 grams per moles for our sulfuric acid. We're then going to be able to convert our 4.9 grams to a 0.05 moles. So just using dimensional analysis here to go from grams to moles. Now that we have that in moles, we need to make sure that our volume is in liters, so 500 milliliters. Setting up the dimensional analysis would get you 0.5 liters. Now that I have moles and liters, I can go ahead, fill in my values into the molarity calculation, which is moles over liters, and then I get 0.1 molar solution with a capital M again. All right. So our molarity formula, and this is on the back of your reference table, is moles of solute over liters of solution. So you have to, again, make sure the big thing is making sure your units are in moles for your solute and have to be in liters for your solution. So when you dilute a solution, only the amount of solvent changes. The moles of the solute actually remain the same. Therefore, the moles in our solute in the original solution is equal to the moles of the solute in the new solution. Since the molarity is equal to moles of solute divided by liters of solution, we can rearrange that to solve for moles of a solute so that molarity times the liters of solution. So that eventually arrives us at the fact that if moles of the original and then the diluted ones are equal to each other, then the molarity times the volume of the original is equal to the molarity and volume of the new solution after it's gone through a dilution. So this is a formula that we're going to then use. So here's a sample calculation. A student has 30 milliliters of an 8 molar solution of potassium iodide. To what volume must the student dilute this in order to have a 0.4 molarity solution? I use this calculation all the time when I'm preparing, especially solutions in our acid and base unit that's coming up. I'll use this so I can dilute it correctly. So here I have MV1 times MV2. We're going to plug in the fact that we have an 8 molar solution and we have 0.0300 liters. Now remember that molarity, if I can bring this up with the pen, molarity is moles over liter. So our volume has to be in liters. So I've simply taken this 30 milliliters and divided it by 1,000 in order to get my 0.03 liters. And then I have that set equal to my new molarity of 0.4 and my missing volume. All right, so in order to get this proper molarity, I'm going to need to have a total solution of 0.6 liters. Now the question asks what volume must the student dilute this to in order to get this 0.4 molar solution. It would be to 0.6 liters or 600 milliliters. So I'm going to have to add 570 milliliters to my original 30 milliliters. And that's all there is to it. So we'll work on this a bunch tomorrow and then review all the calculations that we've done so far for this unit.